Hello everyone. We will discuss about a very important topic like infiltration. In this topic, in the hydrology and water resource engineering, very important infiltration in the runoff calculation and also the measurement of the precipitation is also affected in the infiltration calculation. In this one, today's topic, we will discuss some of the contents, how we have to we are going to be discuss about some of the topics. The first one is infiltration and percolation, and second one is factors affecting on the infiltration and measurement of the infiltration and W index and phi index. These are some of the contents in the infiltration. In the infiltration, so what is meant by infiltration? Infiltration, they enter the water which is entered into the soil through the soil surface is called infiltration. The water which is entered, as previously we discussed about the precipitation. On that time we have to discuss some of the definitions like infiltration, evaporation, transpiration, like that. And here the infiltration is the water which is entered into the layer of the soil is called the surface, is called infiltration. Next, what is percolation? Percolation is the process of the downward movement of the water. The process of downward movement of the water from the into the soil. Once the water enter into the soil, the top layer already precipitated. So again, it can be water can be flows in the downward movement. That is called percolation. In the top of the layer, first it can be wet, while absorbing the rainfall is called infiltration. That is the difference between the infiltration and percolation. So when this is some relation is there, when the percolation will be stops and infiltration is also stops. So and when infiltration stop, percolation is continue. What is this one? In this one, we should have to understand when the percolation stops, so infiltration is also stops. It means the water which is already entered and already going to be downward movement and due to the percolation process, and the infiltration also stops means the above water which is from top to bottom layer. So that's why there is the interrelation between the percolation stops, automatically the infiltration stop. Whereas when the infiltration stops, the percolation is continuous. Percolation will be the continuous. Let's next see. What is meant by infiltration capacity? In this diagram, we will understand it. What is the in the exercise? Some of the etograph is drawn here. Initial infiltration. So some duration is come and discharge can be in the right side will be given. There is some duration of the time. How much can be the infiltration process by using the etograph. So here let us see that one. So infiltration capacity. So it is defined as the maximum amount of the water per unit of time that can absorb under the given conditions is called infiltration capacity. By using this diagram, so etograph, we have to understand the infiltration capacity for certain duration of the period, how much the amount can be infiltrated, can be calculated. So greater infiltration capacity of the soil, the greater amount of the water that can be infiltrated. Next one, field capacity. In this one, what is meant by field capacity? In the field capacity is the volume of the water that can be ground or soil can be hold. Some of the hold the water to the field is called field capacity. So how much amount of the water it can be stored inside the ground, we call it as field capacity. So another definition is interception. What is meant by interception? Interception is nothing but the part of precipitation that are while falling on the earth surface may be stored or collected by the vegetation cover and the subsequently evaporated is called interception. So the why we have to learn this such type of the definitions means in the next slides we can understand easily what is meant by infiltration and what is meant by interception and the field capacity. we have to understand the subject easily. So the volume of the water, that's loss of the water, interception losses. So next slide. So infiltration capacity will be the in this one different type of the availability of the soil. The first one is sand. How the sand will be the infiltration capacity in this one? The pore will be the like that, and the silt. The silt is also the water which is also entered. So sand is the best infiltration, which water is going to inside due to the uh, porous material. Here see that one above the is also the infiltration. So in this one clay, the infiltration is also very less. When compared these three, the infiltration will be the more in the sand and moderate the silt, and the third one is the silt one. That is the infiltration calculation. Infiltration, we have to understand the small. So in the percolation, once the infiltration percolation directly interrelated, then percolation stops and infiltration also stops, already in the discussed in the previous one. Next, in the infiltration curve, there is some formula to find the infiltration capacity, that is equal to Ft is equal to Fc plus F0 minus Fc into e to the power of A into T. So here the infiltration occurs only when the after interception and depression storage losses will be there has been satisfied, then only the infiltration occurs. So that's why from this one we have to find one formula to calculate infiltration capacity. Here Fc is equal to initial infiltration capacity and Fc is equal to limiting constant value of the infiltration. So in this formula we have to find the infiltration capacity curve can be drawn. Next, infiltration can be soil can be identified the maximum rate of which they capable of absorbing the capacity of the water. So it can be denoted by generally I is greater than equal to F, then Fa is equal to upon this soil capacity, and I is less than F. Here Fa is equal to I depends upon the, here I is greater than the F is equal defined as soil capacity, and I is less than F. Fa is equal to I depends upon the rainfall intensity. Where Fa is equal to actual infiltration capacity, I is equal to rate of rainfall, and F is equal to infiltration capacity. This is also the formula to find the infiltration. So let us go in on the another content. The second content is factors affecting on the infiltration. From this one we have to discuss about what the definition infiltration, how the infiltration will become. So next, factors, either any factors can be affected in the infiltration. So yes, there is a lot of factors affecting on the infiltration. The first one is vegetation cover, and second one is moisture content, and third one is temperature, and fourth one is intensity of the rainfall, and fifth one is human activity, and sixth one is quality of the water, and seventh one is movement of the man and the animals, and eighth one presence of the groundwater table, and size and characteristics of the soil particles. So these are the some of the factors will be affecting on the infiltration. So let us see that one by one. Here first one is vegetation cover. In this vegetation cover means the density of the vegetation increases the infiltration bare land which cause the washing of the fine particles of the soil. It means the in the grass or which is already vegetation cover will be and when compared to the bare land, so it can be stops the water and reducing the runoff. For reducing the runoff, the infiltration capacity will be the automatically increases. That is the main cause to increase the vegetation in that areas. So that is the main affected in the. If the vegetation increases, what happens? The infiltration capacity is also increases. To the stopping of the water to runoff can be decreases, to automatically increases. Directly proportional to the vegetation cover. Next one is moisture content. The second one is moisture content. How the moisture content can be affected in the infiltration. In the moisture content, how it can be affected? The infiltration rate depends upon initial moisture condition of the soil. When the soil moisture is high, infiltration rate is also the high. That is a very important point. Here it means the infiltration depends upon the initial moisture condition of the soil. When the soil moisture is high, the infiltration rate is slow. So it is inversely proportional. It means the water which is already absorbing some water, so the infiltration also increases due to primary absorbing the capacity will be decreases. That's why automatically the infiltration will be slowly decreasing. The infiltration capacity slowly decreasing like that. So this is the time interval, and the infiltration can be the discharge centimeters per hour. So that is this is also main cause of the moisture content can be affected. The moisture content will be the also rate of the moisture in the atmospheric conditions. There is a moisture content. Automatically, the infiltration capacity will be the slow. Next, how the temperature. How temperature can be affected? If the temperature will be increases in the season of the summer season, how definitely temperature will be increases. The increase in the temperature reduce the viscosity. So the infiltration when the high, when the temperature is high. So what is the reason one? This in the summer the infiltration capacity will be the high, and the winter the infiltration capacity will be the low, as we discussed in the previous one. So the summer automatically there is a lot of hot weather condition. The infiltration capacity will be the increases. So that is the main cause. The infiltration is high when the temperature is also the high. So that is the one of the factors affecting on the temperature. So next one is intensity of the rainfall. Very important, intensity of the rainfall. In the intensity of the rainfall, in this one, the high intensity of the rainfall causes the mechanical compaction of the soil, and so the heavy intensity of the rainfall causes of the less infiltration. So it can be less intensity rainfall causes high infiltration. So that is the intensity of the rainfall. So duration of the time which is the correct the rainfall, which is calculating the or measured the rainfall will be the affected in the intensity. So in the intensity means lesser intensity rainfall causes of the high infiltration. So next, human activity. What is the human activity can be affected in the evaporation? That means the cultivation on bare land which increase the infiltration, construction of the roads and buildings with increase in the infiltration capacity. With increase in the infiltration capacity. It means in the cultivating on the bare land, which is the increased infiltration. So let us see the one. In the cultivation of the bare land will be increased in infiltration means here as in the first one the vegetation will be increases. What happens? Automatically the infiltration capacity will be the increases. That is the also the cultivation on the bare land. The bare will cultivate the holding capacity will be the increases. Yeah, definitely, automatically the infiltration is also increases. Next, the construction of the roads and buildings will be decrease in the infiltration capacity. It means so due to the concrete top, so it can be by closing all the areas which is the infiltration capacity can be decreases due to concrete tap, due to urbanization, like that. The roads, whatever it is, the increasing the urbanization, the water, the infiltration capacity means the availability and absorbing the capacity, the infiltration capacity will be decreasing all area which the human is activity will be going on heavy. That's why in this one, cities and major cosmopolitan cities and towns, whatever the medium towns will be district headquarters. Generally, due to the heavy of the population and constructions, due to heavy construction, it also can be affected in the infiltration due to increase in the concrete top, the lot of construction of the roads or railway bridges, and also uh, in the buildings. In the buildings will be the also affected in the, this also comes under the human activity. So automatically the infiltration capacity will be the decreases. That is the human activity. Next, quality of the water. Next, how the quality of the water can be affected. So in the quality of the water will be affected, the silt and other impurities of the water, resulting in the reduction of the infiltration. It means the silt contents which is inside the water will be also goes inside, and it can be it can be it will not flow the water from the silt particles. It can be stagnated and it cannot be flow from this one. So that is the silt of the can be main affected in the decreasing of the infiltration. So it means the silt impurities will be the more, the infiltration capacity will be the decreases. So that is the main effect of the quality of the water. Next, movement of the man and animals. What is this one? In the heavy movements of causes of the compaction of the soil and result less infiltration. It means, so just like the people which is the floating of the some certain area. So from this one, what happens? The compaction due to the always using the such type of the area, the compaction will be increases. Automatically the water absorption capacity will be the decreases. That is the main effect of the movement of the animals. Okay, man movement and man animals, how it can be affected, let us see. So heavy movements of the causes of the compaction of the soil due to the most of the people which is also using the such type of the area always. So such type of the things, due to the using of the always, the what happens, the compaction will be increases. Automatically it can be the infiltration capacity of the soil, the porosity will be the decreases. So that's why there is a infiltration capacity also affected. Next, presence of the groundwater table. In the presence of groundwater, it means in this one, the very nearer to the groundwater table in the percolation, the infiltration capacity will be the less. Why? Because here, for suppose here is that there is the water table is here inside, and the infiltration of the water very nearer to that one. It means it can be due to the capillary action, whatever it is, the water particles, it is also the moisture content can be affected in the top is also. That's why the infiltration capacity, there already the water moisture content is there. So that's why the infiltration capacity will be the decreases for this one. That is the presence of the groundwater table. Near the groundwater table, the infiltration capacity will be the less. So that is the one of the point. Next, size and characters of the soil particles. That is a very important. How the size of the particle. As we discussed in the previous slides, what happens? The size of the particle, the silt particles which is also inside and which cannot be flow of the water from this one. In the sand particles which is already increasing the infiltration. Why? Because the porosity will be the increases. So that is the infiltration directly proportional to the grain size, diameter of the granular of the soils, and in other materials like illite and monomortolite, the infiltration rate will be the reduces drastically. It means, so the what is the spinate particles which is also gone inside and stagnated, it will not flow the water. So that is the main important of the size and characteristics of. If there is size will be increased, what happens? There is a lot of gaps inside the each of the particle, automatically the absorbing capacity, the infiltration capacity, percolation will be the automatically increases. That is the very common. So that's why the affecting of the size of the granules and depends upon the size of the particles and sand particles, and also the type of the soils can be also affected in the infiltration factors. So measurement of infiltration, let us see. In this measurement of infiltration, what happens in the infiltration characteristics of the soil given the location can be obtained the conducting controlled experiments on the small areas. Control the small areas. So that is the main effect of the infiltration. Is there any devices to calculating the measurement of the infiltration? Yes, there is a lot of devices can be calculating the measure the infiltration. So infiltration can be, which is called as infiltrometers. We call it as infiltrometers. So infiltration device, the rate of infiltration of the soil of the determined type of the soil. So it will be by calculating the infiltrometer by applying. So the depends upon the soil conditions, geological conditions, and the temperature. As we discussed the previous factors will also lot of affected for the infiltration. Let us see here. Infiltration can be bifurcated into can be calculated. Infiltration can be calculated by using the infiltrometers, and infiltrometers can be bifurcated in the flooding type infiltrometers and rainfall simulators, and again it can be bifurcated flood type infiltrometer, single ring infiltrometer, and double ring infiltrometer. These are the infiltrometers while calculating the infiltration. So let us see that one. Infiltration infiltrometers can be single ring, single tube or ring type infiltrometer. Generally we call it as single ring infiltrometer, and double ring infiltrometers we call it as. So see that one here, the single ring infiltrometer. Above that one, the diagram. So it is the 50 centimeters taking inside the ground, when the diameter will be taken as ring of the generally 30 centimeters, and ring length is equal to 60 centimeters, and ring driven into the soil is equal to 50 centimeters, and the water level is maintained the 5 centimeters. So that is the dimensions of the given the single infiltrometer. So this is a practical one, how they are calculating infiltration of the duration of the 2 to 3 hours, how the infiltration can be increases. See here, the volume of the water added during the different times of the intervals, the plot of the infiltration capacity versus time is obtained. So that is the uniform infiltrator can be applied. From this one, we have to prepare one graph like that, time and the duration of the time, and how much the water can be infiltrated on certain duration of the 0, 2 hours, 4 hours like that. So for this one, you have to find out all the infiltration. So that is the single ring infiltrometers. Single ring infiltrometers of the dimensions and specifications are there. From this one, each of the 2 to 3 hours, as per the site conditions, we have to calculate the infiltration, how much by using the single ring infiltrometers. Here see that one 30 centimeters. Above is 10 centimeters is there, above 10 centimeters here. That is the important. And 5 centimeters is the total 10 centimeters. 5 centimeters can be maintained as water level above the ground. That is the very important. From this one, we have to find out how much water can be infiltrated on certain duration of the time. That is the single infiltrometer. Next, as it consists of the 50 centimeters, as these are dimensions. Here the length of the cylinder is equal to 2 into diameter. Generally we take it as 2 into diameter, and of course it is prevalent to the level of the ground 10 centimeters and above the ground, and the core of the part of the depth 5 centimeters, and the pointer is set to inside the ring, indicate the water to be maintained. So 5 centimeters can be minimum you have to find out. So each and every 2 to 3 hours, how much it can be infiltrated can be taken, and again it can be measured how much the water can be infiltrated by using the single ring infiltrometers. So next, it can be driven into the ground, as we know that, and also the amount of the water ring, how much the water, it can be depends upon majorly on the single ring infiltrometer and site conditions and type of the soil, as we discussed earlier. So it can be how much the 2 to 3 hours duration, how much the water can be infiltrated can be noted. Reach and 2 to 3 hours. 2 to 3 hours can be noted. That is important. Next one is double ring infiltrometers. After some of the drawbacks can be raised due to the single ring infiltrometer, they are using the double ring infiltrometer. Double ring infiltrometers consists of the here without disturbing. This is most commonly used the flood type infiltrometer, and they consist of the 2 concentric rings. Instead of 1, we have to use the 2 rings. Inside ring and outside ring can be used. The dia of the rings maybe varies 25 centimeters to 60 centimeters. The inner ring of the driven to the ground, and the second ring around the help of the control and flow of the water through the first ring. Water is supplied either with a constant or falling head and condition, and the operator records how much the water can be infiltrates from the inner ring to the soil over the given time period. So this can be double ring infiltrometer. Let us see in the diagram, you can understand easily. Here, see that one, double ring infiltrometer. Here the single infiltrometer is there, and another outside another one of the infiltrometer can be inserted, the green one. So this is the why we are using the double infiltrometer means. Before going to discuss, let us see the dimensions of the clearly given. Metal of the ring is a metal cylinder, and a ring diameter is equal to 30 centimeters to 60 centimeters, and ring length is equal to 25 centimeters. Our link driven into the soil is equal to 15 centimeters. Water level in the maintained is equal to 5 centimeters. So this is the common dimensions are which is given in the double ring infiltrometer. What are the from the overcome the drawbacks? Both rings should be have kept the same duration and the observed period. The measurement is taken only from the inner ring. Here drawbacks. What are the drawbacks can be considered in double ring infiltrometer means. Here the major one is the water which is infiltrated from the outside from the sides of the some of the water can be waste. So that's why you can absorb the capacity in the surroundings of the single ring infiltrometer. So that's why we have to provide another double ring infiltrometer can be provided instead of single ring infiltrometer. But here is the majorly we have to calculate take it measurement will be considered as inner ring only. So outer ring is only for supporting for reducing the infiltration. So that's why we have to provide instead of 1, 2 rings can be provided for calculating the infiltrometers. As consists of 2 concentric halo rings can travel into the soil as uniformly without any tilt or disturbing the soil. That is the main important point. So without disturbing the point means while inserting in the ground in the double ring infiltrometer, what happens? The soil will be disturbed and it can be loose, maybe becomes too hard to loose soil. The infiltration will be the changes due to when compared with the compaction soil as well as on the loose soil. That's why the very important point is okay. So by overcome this first infiltrometer, second infiltrometer can be without disturbing of the soil, we will be considered and can be provided and take it as measurement and measure the whatever the infiltration on duration of the certain period. So this is also double ring infiltrometer will be given. So that is the 30 centimeter, 60 centimeter, like that. This is also another diagram. Water level can be measured, can be here, see that one, how one side can be used for the how the water can be infiltrated, and some of the points can be given. This is also one of the diagram in the. So this is a practically what we have to apply. The single ring double ring infiltrometer is there, and single ring infiltrometer is there. This is single one and double ring infiltrometer. See the sides of the water. It means the sides of the water which is reduces the infiltration. That means we have to know the actual infiltration on that certain soil can be known. That's why we have to provide it instead of one double ring infiltrometer can be providing. That is the single double ring infiltrometer. And single ring infiltrometer is there also here. So like you see that one which is collected from the textbook. So whatever it is, so this the diameter is single ring, double ring. Here that one, see the infiltration capacity will be the inside, will be the absorbed some outside the wastage. So that's why instead of this one, the water will be here. See that one directly the water which is infiltrating in the double ring infiltrometer. It cannot be flow in the sides of that one. So that's why the water which is flowing on the sides only the outside infiltrometer only. So but we have to consider here only the double ring infiltrometer only. So that is the main causes the infiltrometer. So that is the instead of single infiltrometer, we have to provide double infiltrometer for accurate measurement of the infiltration. Next one is rainfall simulators. In the rainfall simulators, how the rainfall simulators can be affected? In the rainfall simulators is also one of the technique for calculating the infiltration. For this one, the field test can be provided. Take it as 2 meters by 4 meters size of is provided, and with the series of the nozzle on the longer side and the arrangement to collect to measure the surface runoff rate, and the special nozzles can be raindrops falling in the height of 2 meters height from the and also capable control the conditions of the various conditions of the intensities of duration. A different type of the intensities, different type of duration will be considered, and this is also practical one, and also by applying the infiltration various time can be estimated. Here P minus R minus G minus E minus T minus delta S. So for this one we have to, what is this one? Let us see the elaboration. P is equal to precipitation, R is equal to surface runoff, and G is equal to net ground, and E is equal to evaporation water, and delta S is equal to change in the storage. In the change in the storage calculation, we will apply this formula. We have to find the infiltration by using the rainfall simulators. In this diagram, you can understand it easily. See the diagram, the above the nozzle can be provided on the top of 2 meters above, and the water is going, water pressure can be gauge can be how much the water can be pressured, can be flowing in this pipe, and rainfall simulators can be provided here. From this droplet, it can be how much the water of the duration from this span on certain duration time, how much the water can be absorbed and infiltrated can be calculated here by the practically. So this is the rainfall, another method for calculating the rainfall simulators. So this is second one, rainfall simulator. This is the easiest one to calculating the rainfall simulator by applying the above. By this is the one of the setup can be provided by calculating the on certain area of the infiltration calculation. So here see that one, let us the plots can be taken as we discussed, 2 by 2 meter size water level, and specially designed nozzles can be used for the 2 meters of the height, and also this gives the lower value of the flooding infiltrometer due to the effect of the rain impact turbid of the water. This is also two types of F and FA used for the greater accuracy can be used. This is also one of the technique for the method for the calculating on the infiltration. So what are the disadvantages for the infiltrometer? In the single ring infiltrometer disadvantage, water is spread over the immediately from the bottom, which does not represent true infiltration of the bed. As I told you in before, see that one, the diagram. See here, the single infiltrometer, the water which is flowing here outside can be, that is the main drawback. The infiltration we cannot be correctly, it cannot be calculated, the measured the infiltration capacity in the single infiltrometers. So this is that one, the water which is sides can be also going, and less value can be infiltrated by inside. That is the drawback of the single infiltrometer. See here. And double infiltrometer disadvantage is size and effect. Size effect. So larger diameter infiltro given the more accurate, and the lesser value of the infiltration is smaller diameter. So the boundary can be affected. How the boundary can be affected? So in this one, in the single infiltrometers, double infiltrometers, the boundaries which is affected in the temperature, the conditions, whatever it is, the temperature is due to the summer season, due to increasing the radiation in the temperature, automatically the infiltration capacity can be increases, and also the sides will be also affected, the inside the water, some of the evaporated is also. So that's why there is the boundaries can be affected in the double ring infiltrometer disadvantage. Next, a disturbance of the original soil due to the driving into the rings. So you cannot be disturb the soils in the while doing the practical. So inserting of the here, the inserting of the driven into the ground, we cannot be disturb the surroundings of the soil. That is the main causes. Taking care on that one by inserting on the infiltrometers inside the ground, that is the very important. So by these methods we are calculating the infiltration. So what are they? The single ring infiltrometers, double ring infiltrometer, and next one is the infiltration simulators. By applying the simulators, we have to find the infiltration, and taking the values of the duration of certain period, the infiltration can be affected. How the infiltration on certain area. By previously we discussed about some of the factors can be also taken in the considerations. Can be infiltration can be calculated. Thank you. Thank you very much. The next WTX 5 index can be we'll discuss about the my next video, and solve some problems is also there. So that is the I'm closing here. So thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.